Alright, 2015 AB Calculus Test, question 2, this is part A. They want me to find the sum of the areas of regions R and S. So find the areas of these two, add them up. I can see, so I know from these functions, 1 plus x plus e to the x squared minus 2x is going to be this bottom function, sort of like an exponential growth function. And then this top function, so I'm going to label that this one is f. The top function is this g of x. It looks like it has a fourth power. It's a quartic function. So I'll put g up there. So what I need to do first of all is find this value, because from 0 to this value, and I'll label this value as a, g is going to be bigger than f. And then from this value to 2, f is going to be bigger than g. So I'm going to end up eventually doing the integral from 0 to a of g of x minus f of x dx plus integral from a to 2 of f of x minus g of x. And that'll be much clearer once I do the graphs. You can see in the graph which one's which. If you happen to mess up which function's which, you'll just end up getting a negative. You know areas can't be negative, so you'll just sort of flip g and f, and you can get the right answer that way. You could also have done it as the integral from 0 to 2 of the absolute value of f of x minus g of x dx. I don't like that way. It's not as clean. It'll take the calculator a long time to figure out this through the absolute value. You don't figure out what happens here, which may be important later on in the problem. So I'm not going to do it this way, but you will get the right answer because this will ensure that you always have the correct function on top. So if you want to, feel free to do that. All right, so let's go and do some calculator work here. So I will go to my graph. I will graph f of x in this y1. So I have 1 plus x plus e to the x squared minus 2x. And I'll graph g of x in the y2. So I have x to the fourth minus 6.5 x squared plus 6x plus 2. And let me see. So this goes up to 2, 4. So I'll go and change my window straight away. I'll go from, let's say, -1 to 5. That'll cover the x nicely. And I'll go from -1. Oh, sorry, that doesn't need to be to 5. -1 to 3, because this only goes to x value of 2. I'll go this y value from -1 to 5. That'll cover the y nicely, and it should look very similar. We'll know if we are wrong, because this won't look close to that. We know if we typed in something wrong, at least. Okay, so I'm going to go ahead and find where those two meet. So second calc, intersect. It's already close, so the first curve is f of x. You can see up here it's listed off. Second curve is g of x. You can see right there it's listed off. The guess, well, that's pretty close. And it tells me that they intersect at approximately 1.0328319. So A is approximately 1.032. Let me click that calculator. Make sure I don't forget 8319. Now that's nice. You're going to write that down so I can use the A in my problem throughout. And then I'm going to go ahead. Now in the calculator, I don't need to rewrite it because if I go out here, it's already stored in X. So I'm going to go ahead and just store that in A. Okay, and I'm just going to do this work using that a value. So math 9 for the integral, g of x minus f of x. So I can actually, instead of typing them in, I already have them in y2 and y1. So I'm going to do that trick if I can remember how to get there. There we go, function. So g was y1 minus var's function y2 with respect to x from 0 to a. And I'm going to add on the integral of f minus g. Hold on, this should be y2 minus y1 other way around, because it's g minus f for that first one. So g minus f, and this one should be f minus g. So f was in y1, g was in y2. With respect to x, from a all up to 2. Press enter, and I get, once it does the thinking, approximately 2.004.